So today's lecture is going to be a bit interesting because here we are going to talk about synthesis. So I hope that most of you are familiar with this particular word synthesis because very common word and it is used in a number of fields and variety of people use it for different purposes. Now the point is that as a new user, if we are coming to the field of speech and we are talking about synthesis, then what does it mean? So again, two terms are there. One is speech, second is synthesis. Everyone knows about speech. What is it? Is nothing but some voice sample, a human voice sample in general. And synthesis, what it is nothing but the formation of something out of something. So if I break down, then normally synthesis is something when you have multiple things, means different traits of something, and then you are combining it and having something out of it. So in short, if we say when you form some system or something out of the existing components, then you are synthesizing a particular system. So similar way, here we have the speech synthesis. In this way, you are synthesizing the speech out of something. So for example, there are number of different text portions or something like that. And then you are converting those portions, means you are combining or having a sort of permutation of those portions, and then you are deriving a speech as output. Then it is speech synthesis. So let's start. This video is going to be interesting because we are going to talk about some of the related portions, having the technical details. Then we are going to discuss some of the data sets, some of the key components, and the works that you can do in this particular domain. So we are going to start it with the basic definition. So here the basic definition says that the Google says that it is nothing but turning text into natural sounding speech. And if we talk about the Wikipedia, then Wikipedia says that it is nothing but the artificial production of human speech. So in short, the same thing that I'm telling you, that when you have some sort of different input, for example, text input or some other sort of artificial input, and then you are converting into the image form, into the speech form, then it is speech synthesis. So that's the basic definition. Let's close it. Now coming to that, if it is like this, then is it the kind of process? So the process is something like this. So here you have the reference audio. If you want to have this particular portion of reference audio and you have the post audio embedding, then it's fine. Otherwise, you can just means just forget about this particular portion. Just to simply focus on to this part. That's input text sequence is there. Some text is there. Then you have some text encoder, and then you are applying some sort of conditioning based on the post audio embedding. But if you don't have this particular part, then obviously this particular part is not available. Then you have the sort of attention part, then you decode it, and then you have the synthesized audio. So that's the in general process, but it might not be always like this only. There might be some sort of enhancements, some different modules which are improving the synthesized audio. So that's the process. Now coming on to the specific sort of discussion with respect to speech synthesis. So here at this particular work, the wavenet means it is a work that is a generative model for raw audio. So they are trying to produce the raw audio and with the help of a generative model, and this is available at deepmind.com. So if you are interested, you can go and have a look onto this particular blog. So there they have talked about the talking machines. It is nothing but the sort of computers or the devices which are producing some sort of voices or the raw audio. So that's why they are saying that these are the sort of machines which are having some sort of talking capabilities. Yeah, so if multiple machines are having same sort of capability, then obviously they can interact and have a sort of chit chat or discussion among them. So that's the whole idea behind this particular thing. Now, when they are talking about the webnets, and they are talking about the different sorts of related technical terms with respect to the sort of neural networks. Then they are talking about the state of the art, etc., etc. Different sort of things are there. So if you are interested, you can go and have a look onto this particular blog. Not very long, but a very good blog. Then moving on to the specific research work, because in our most of the videos we discuss at least one of the works to give you a actual insight of our research work, how it looks like, because most of my videos are targeted towards the new audience, means the new researchers, because they don't know that how to start, where to go, and how to find the things. So we are trying to cover at least one of the work where they can go and have a look at that, how it looks like, how they can start and sort of things. So it is the hi-fi GAN. GAN stands for the generative adversarial network. And again, it is related to the AI domain. So if you are an AI person, then obviously you do know about this particular thing. But if you are working in the field of audio, then again, you do need some sort of automation. So that automation might come from the ML domain or the AI, or from the DL domain, deep learning domain. So that's up to you. But coming to this particular work, what they are talking about the efficient and high fidelity speech synthesis. That's the sole motive. Doesn't matter which particular technique or technology they are using GAN for it, but you might use something other. So the only purpose is that you are trying to produce the efficient and high fidelity speech synthesis. That's the sole purpose. So here, if you go, then they have discussed in the abstract that they have tried different sorts of methods, and they have shown the different sorts of fidelity with respect to the different sorts of audio. And then they have further shown the sort of hi-fi GAN and its spectrogram inversion to the speakers and to-end speech synthesis also. So that's the whole demonstration. And in the last, obviously, the hi-fi GAN generates the samples 13.4 times faster than the real time on CPU with the comparable quality to an autoregressive counterpart. So that's the whole idea behind. If you are interested, if you do know all these terms, then it is good to make a basic understanding. But if you are new to the field or if you are a new researcher, then obviously these things are not going to make sense to you. So just leave it, just simply go on and just have a basic look onto the work. Starting with the basic introduction, you are going to have the basic introduction of the voice, what is the process of making neural networks, how to do the speech synthesis, etc. All these things are discussed in this introduction portion. Then they have discussed the hi-fi GAN, offering a basic overview of GAN, that what is the generator, etc. Then they have discussed the concept of discriminator. Then moving on to, they have the sort of training loss terms. So if again, as I told you, that if you are a person of AI, then obviously these things are going to be a bit easier for you. Then they have discussed the experimental details, and finally they have put the audio, and they have done the sort of comparisons. So all these things are available like a general paper, but the point is that whenever you are going for the speech related research, or you are working in the field of synthesis, then there are some of the key related details which you must be familiar with, because in any field, if you are having the key sort of related details ready at your hand, then it becomes very easy. So again, let me cover it up and conclude the topic that what is speech synthesis? It's nothing but the task of generating speech from some sort of different input. For example, it might be the text, or it might be some sort of lip movement or something like that. Okay. Additionally, when you are discussing this particular work, there are a number of data sets and the different models available. So the LJ speech and the North American English are some of the related data sets. Additionally, you have the Somos, you have the Gumar corpus, you have the Portuguese corpus. So all these corpuses are available for your research purposes. So if you are interested, you can go and have a look onto this. Additionally, there are some of the related techniques with respect to image, speech synthesis, which are very much going to be useful. But it also depends on what sort of technology or the technique you are using for speech synthesis. So I'm not going much into the details, because again, the video will go longer and it will be difficult as a beginner for you to just go on and have a kind of consistency with this particular video. So we directly jump onto the kind of related works. One work we have already seen. Additionally, there is another work with that is the 2021 work ICLR, and there we have the fast speech 2 kind of title. There we have the fast and high quality end-to-end speech, text to speech. So the related PyTorch implementation and the GitHub repositories both are available. So you can move to the GitHub repository and you can find the related details. Then we have the Melgan, where the generative adversarial network for conditional waveform synthesis is used. 2019 work. It is a PyTorch implementation, and again the GitHub details are available. So all these things, different sorts of repositories, different sorts of platforms which are available for the voice or the image synthesis, voice or speech synthesis, which are ready to be used. That you can go onto those platforms or the repositories, and you can have some sorts of hands-on if possible, because there are different third-party applications which are offering you some sort of hands-on practices with respect to the image, the audio and voice synthesis. So it becomes very much helpful for a naive person, for a starting researcher, to have a hands-on application where they definitely get to know that what is the whole idea of speech synthesis. Then concluding this particular video, let me tell the names of 2-3 more works. One is the style tokens, where the unsupervised style modeling and the control and transfer are used for the end-to-end speech synthesis 2018 work, and the GitHub repository is available. Additionally, the Neuro IPS 2018 work having the TensorFlow implementation with the title Transfer Learning from Speaker Verification to Multi-Speaker Text-to-Speech Synthesis. That is another very important and good work where they have discussed the real-time voice cloning. So that's the whole and the maximum possible content from my side in the minimum possible time. If you didn't like anything, please do comment below and criticize the video. If you did like something, please do comment below also, and let me tell that what are the portions which were good and which need more attention. So that's all for this particular video. Thanks for watching. Happy learning.